Alrighty, today our objective is that you can apply the Pythagorean theorem to 3D figures. So these are all going to be two-step Pythagorean theorem figures or Pythagorean theorem questions. They're all going to require you doing it twice. So the warm-up here is that Lindsay wants to mail a candle that is 8 inches tall to her friend. For her birthday, and she needs to know if the candle will fit diagonally in the boxes. So she wants to know if the candle would fit on this orange line that I'm creating here. So describe how Lindsay could use the Pythagorean theorem to help her answer the question. Well, my first instinct would be to go 4 squared plus 7 squared, and that would get you that diagonal. But that gets you a different diagonal, this one over here. That's not what we want. We need to know if this one here is 8 inches. So what we actually need to do is we need to find the diagonal here at the bottom so that we can have a brand new triangle, and that is this orange triangle that I have highlighted here. So the first step is to find this diagonal one. Well, to find this one, we have 3 and 4 as our A and our B. So we have A and B here. So the first step is to find the diagonal distance across the base is the first step. The next step would be to then, using that, find the diagonal difference, diagonal distance of the box, which is that orange triangle. So we first have to figure out the base of this orange triangle. Doing that, we would do 3 squared plus 4 squared equals c squared, which is 9 plus 16 equals c squared, which is 25 equals c squared, which means c is equal to 5. So this bottom length is 5. So then you have 5 and 7 as your bases or your legs of this other triangle here. So then you have 5 squared plus 7 squared equals c squared. And c squared, this is your c squared here that you're trying to figure out if it's over 8 inches. So you have 25 plus 49 equals c squared. And 25 plus 49 is equal to 74 equals c squared. And the square root of 74 is equal to 8.6, which is taller than the candle. So yes, she could fit that 8-inch candle into this box. So we are going to go ahead and do another one of these. So again, I'm going to kind of highlight your triangle in orange. You have 2 triangles you're trying to focus on. This ending triangle is this one right here. That is the ending triangle we're gonna have. To find that, we need to find the distance of this blue triangle, right? Because this blue, our hypotenuse of our blue triangle and the legs of our orange, and one of the A's or the B's, one of the legs of our orange triangle are the same length here. I know the drawing makes it not exactly perfect, but this would be our other triangle here. Again, it's not exactly perfect, but there you see. So that B, this distance here, is C of this triangle, 3, 6, and 9, and it's going to be the B of this other triangle here. So you have 13 squared plus 6 squared equals C squared. And you are going to get 13 squared is 169 plus 36 is equal to C squared. 169 plus 36 is equal to 205 is equal to C squared. The square root of 205 is equal to C. So C is equal to 14.3. Equal to 14.3. And I find that by hitting the square root symbol on my calculator. Now that I know this is 14.3, I can actually plug it in as the B to this triangle here to find this distance C. And that is ultimately what I'm trying to find is AB. So I would get 13 squared plus 14.3. 14.3 squared is equal to C squared. And then your 14.3 your 13 squared is equal to 169 again. 14 squared is equal to 204.49. Your is equal to C squared. Your finally answer is 373.49 is equal to C squared. And then you take the square root of that 373.49 and you get that C is equal to 19.3. So your final answer would be 19.3. So the length of AB is equal to 19.3. So again, these are multiple steps, but once you get the hang of it, it becomes pretty easy. And it's not a whole lot more work than we've been doing all along here. So again, we have the triangle here of that we are ultimately trying to find the distance of right here. It's not perfect. And then we can do that. We can find this bottom distance because we have the distance for this height would be 15, right? We don't know the bottom distance. We can find that distance by finding our A squared plus B squared equals C squared of 8 and 24. So we have 8 squared plus 24 squared equals equals c squared. So we have 64 plus 24 times 24 is 578 squared, or not 578 squared, just 578, we've already squared it, is equal to c squared, which is equal to 640, and then the square root of 640 is equal to 25.1. And so now we plug in so we know that this leg here is 25.1, so we plug it back in. We get 15 squared plus 25.1 squared equals c squared. 15 times 15 is equal to 225. 25.1 times 25.1 is equal to 630.01, and you add the two 630.01 plus 225 is equal to 855.01, and then when we take the square root of that, we get C is equal to 29.2. So our final answer for A, B on this one would be 29.2. All right, next step is we're going to go into pyramids and cones. Parts of the height of a pyramid and a cone will always be perpendicular to the base. This means it intersects the base at a 90-degree angle. In a pyramid, the slant height is the lateral distance from the vertex of the cone or the pyramid to the base, and it will also intersect the edge of the base at 90 degrees. So if we start with R here, H here, what do you notice about this? It forms a right triangle. The same thing happens here when you have H and S of your slant here. A right triangle is formed. A right triangle is formed. So we know because these form a right triangle, we can use our Pythagorean theorem to solve the different pieces of it. So it says the radius of the cone is 14 centimeters. So the radius is 14. So right here is 14. And the height, or the slant height, so remember the slant height is literally the height on the diagonal. The slant height is 28. Now, solve for the height of the cone. So in this case, you have A, B, and C. So you would have A squared plus 14 squared equals 28 squared. So you would have 14 times 14 is equal to 196. So A squared plus 196 is equal to 28 times 28. which is equal to 784. You subtract those two. Six. So you have a squared is equal to 588. The square root of 588 is 24.2. And then if we scroll down, I want you to go ahead and try this one. It's a little bit different, but it's the same thing. This time you are finding C, your slant height. The diameter is 40, so the distance right here is 40. The height here is 21, and you want the slant height, which will be your C. And now we're going to do it with a pyramid. The base of a pyramid is a square length of 30 inches. The height of the pyramid is 50. So you know that from here to here is 30, or from here to here is 50. And then you know all the way across is 30. But you don't need all the way across. You just need halfway from here to here. So that would be 15. Because it is square, you can just do the half. So you would get a squared of 50 squared plus 15 squared is equal to C squared. 50 plus 50 is 2,500, or 50 times 50, sorry. And then 15 times 15 is equal to 225. So you get is equal to C squared. When you add those two together, you get 2,725 is equal to C squared. The square root of 2,725 is equal to C, which makes C equal to 52.2. Go ahead and pause this one. You follow the same steps as we did the last one. Remember, you're going to half this base here because this goes all the way across and you just want the distance here. Alrighty, go ahead and pause that and solve, and have a great day. Bye.